Alright, I said it again. 326, NET-609, network security. We're starting at 8:30. Allows some students who work at night to travel. And this is day 20. We have not missed any days on Tuesday, Thursdays. Review, okay? So we want to make sure we understand keys and algorithms. We use an algorithm to either encrypt our data or to hash the data. Mention key length, like if we use 256-bit key, the key space would be 2 raised to 256, which is some really big number. And that number gets even bigger, as we increase the key, like 1024 or all the way up to 4,000, whatever. Okay, so we understood that, and then we also talked about symmetric algorithms, in which we have a shared key. Okay, so then we talked about key management. You gotta get the key on both ends. And then asymmetric. This is very often referred to as the public algorithm or public key structure or whatever. This is where you have a public key and a private key. You can share the public key, you can't share the private key. One can be used to encrypt the other can be used to encrypt this one. And then if you encrypt with one key, you decrypt with the other. We talked about encryption. These all encrypt, DES and triple DES. I talked a little bit about, I did a report on triple DES back when I was getting my computer science degree. Advanced encryption, seal, you could look that up. Reverse code. These are all popular. There's a few others, and it's not bad to go in and look. Wikipedia does a nice job. You could look those up. We use those to encrypt. We use these to hash, and we also remember hashing. Encryption tends to be confidentiality. Let me hear. I'll get it eventually. Confidentiality. Here we can use these for integrity. Yeah, integrity and authentication. Confidentiality, encryption. Okay? And so we have this. We don't have a standard yet, but standard's coming. We have a standard here and MD5. So those are used. And then we talked about Diffie-Hellman, which kind of extends from all these, where you can pick a prime number. I forget what the G stands for directly, but you can think of it almost like a public key. And then you pick like your private key on both ends, and then you use some type of raise to the power. So you see here 6, 15, and then modulus divides. It gives you the remainder from division. So this is a prime number. We pick the prime number up here. So we take our base number, raise it to our private number, get that calculation, bring it over here, get this calculation, bring it over here. So the 8 came from this work, the 19 came from this work, and now you, again, apply your private key and then do the modulus, and you come out with the same number on both ends. So now, without actually exchanging it, we now have a shared key that we can use. Now, we wouldn't use 2, but you now have the basis to develop your shared key on both ends. Diffie-Hellman. Protocols. These are protocols to apply what we just talked about. Okay? Protocols to apply that. Internet key exchange, secured socket layer, transport layer security, secured shell, pretty good privacy. All kind of have a different place in our world of security. RSA, we can set up a public-private key combination. DSA, same thing, and Diffie-Hellman allows us to do those. Now, if we take a public key plus a private key, that allows us confidentiality of information. So if we take Mike's public key and encrypt it, then only Mike's private key can decrypt it, which then will create confidence in the information, whether we're sending it, it's whether the data is in transit. That's our our biggest concern here in this course. We're talking about the transit, but even the data sitting in stored or the data being processed. We can think about those three, but here we're thinking about data in transit. So encrypt the public key, decrypt the private key. Now, if we're trying to prove authentication, who it came from, then we would encrypt with a private key, then use the public key to de-encrypt it. We would encrypt with the private key to identify who it is, and then anybody could decrypt it. So we did an example. We have a message that we want to send. Okay? So one thing we can do is we can take this message and say this is Mike and say this is Chris. So we can use Mike's public key if we confidentiality, make sure we get it straight here. So actually, if we're going to send the information to Chris, Chris will send his public key. And so let me kind of clarify here. Let's say Chris is going to be green. So Chris will send his public key, right, which he can share. I'll encrypt it with the public key, send the data over, and then, right, Chris is the only one that can look at the data, right, because he's the only one that has the private key. So it's always done in this order. Use a public key to encrypt it, private key to read it. You just have to figure out, get the public key to the right place. Now, if we want to verify, okay, I'll use another color. If we want to verify that the message came from me, I could take the message, okay, I can hash it, and then I can encrypt it with my private key, and then I'm going to send my public key along. So you get it? I'm going to encrypt it with my private key, and then I can send my public key along with it. That will authenticate it, because nobody else could encrypt it with this private key. And so then when it ends up on the other end, okay, I hash the message, so that'd be unique. I encrypt it with a private key, gets the other end, I send the public key, okay, then they can decrypt it. Now they have a hash. Here's the original message. They can hash it. Now they have a hash, and those hashes would have to equal each other. Okay, let me give you another example. We have a document. We hash the document. We encrypt that with the private key, and then we send that with the public key, and then that would represent a digital signature. So you can see there's two processes if you want to take care of both confidentiality and authentication. VPNs, site to site, remote to site. We talked a little bit about hairpinning this idea that so this concept of hairpinning, this is actually from the curriculum. Hairpinning is a term used to describe a situation in which VPN traffic that enters an interface may also be routed out of that same interface. For example, consider a hub and spoke topology where we have, I can kind of draw that out. So here's corporate, and we have somebody coming in, an interface that's facing the internet, and then that traffic can also come out of there to go to public sites. Okay, so we're going through corporate to get to the public site. Split tunneling would be the case where we have a device connecting to corporate and it's also going to public addresses out on the internet. So you'd have to be careful about the security of doing here. So here's an example of a laptop. Okay, hairpinning would be you come in and then you can go out here. Split tunnel, you can go here or go here to corporate. So it's how the security is set up and so forth. But anyway, let's keep moving here. We talked about a framework for IPsec. We have the IPsec protocols we're going to run. What are we going to do for confidentiality? What are we going to do for integrity? And we've really gone over those things earlier. How are we going to authenticate? And our secure key exchange, how are we going to do that? What level of Diffie-Hellman are we going to do? We can have a situation where we set it up site to site, right? We have to set this up on both sites so that they can communicate. Or we can have a remote site coming in. Let me use a little brighter color here. We can have a remote site coming in, and then there can be a number of transform sets. So this one can pick the right one that matches in order to set up our tunnel that way. And these are all set up based on this framework, which is a framework. It's IPsec. It's not just one. It's the framework that all devices and so forth would use. And we wouldn't have to use that for a VPN. I also mentioned at the college, you can use VPNs internally, like when we have an administrator take their laptop out in campus somewhere, rather than plugging it into their VLAN, they're going to use the Wi-Fi. So to secure that better, they will actually run a VPN. I'll try it. Okay, I'm going to try not to make it too long, so I'm almost done. Public key infrastructure. How do we distribute the public key? Right? You don't distribute the private key. Let me overemphasize that. Right? You don't distribute, but you have to somehow distribute your public key. Okay. So we talked about certificate authorities. For example, VeriSign would run something like a public key infrastructure in which they have a certificate authority that would keep a database of all certificates, and then a register authority, so you could go into a register authority and register your certificate so it's stored out there. So when company X is trying to reach company Y, here, okay, company Y, so they have their certificates, and so company Y can always go to the certificate authority and check that certificate, make sure it's accurate. X would keep their private address, Y would keep their private address, and only the public address would be shared out here. So there's a couple different structures. Here I have registration authorities, communicating to here. Sometimes we'll call this the root authority. But there's different ways to manage this. And you could do this, in your own company, okay, your own enterprise. They talk about some protocols they follow in order to secure this exchange and different ways you can do that. You can use secure socket layer, or now transport layer security. S-MIME for email. This allows this for web, for email. This can be where we use 802.1x. Network access control. We talked a little bit about that, like, from the switch. It can authenticate you to a radius server before it even lets you into the switch or the access point, either one of those. And it can even do a bunch of things. It could check your device to see if your virus software is up to date and so forth. IPsec uses this internet key exchange and typically uses RSA to do its public-private key configuration. And I believe, now this is an old shot, but this was what the how the lab is currently set up. And what they did was they created an IPsec tunnel between these two routers. And that is it.